So Phillips curve basically started from the first kind of relationship. Rate of growth of money wage, rate of growth of money wage is a function of unemployment, is a function of rate of unemployment, rate of unemployment. Okay. So the idea is that if in an economy unemployment rate increases, that means there is many surplus labor force in the economy. There are many laborers who remained unemployed, you know. So there are many people who are seeking the job, however not getting the job. Okay. So unemployment rate increases means many people are seeking the job, many people want to join the labor force, however they are not getting the chance. So this is the situation of surplus labor. Now if there is surplus labor in an economy, in that case the price of labor, which we generally call the wage, okay, that falls. That falls. If unemployment rate increases, that in turn indicates there is surplus labor in an economy, and if there is surplus labor in an economy, naturally wage rate or the per unit price we will pay to get that resource, that will fall. Are you getting the idea? Isn't it the natural relationship between the unemployment rate and wage rate? Any question, any doubt, any clarification you need? Are you understanding the matter?
Yes, ma'am.
Yes, ma'am.
Okay. So in an economy, remember that if there is many surplus, you know, naturally price per unit of that resource will fall. So Phillips actually started with this kind of relationship. If there is growing unemployment rate in an economy, there is no employment generation, more people are seeking the job, rate of unemployment is increasing. In that situation, we will go for very cheap labor. You know, we will pay very small amount to the labor force. So wage rate will decline. So there is an inverse relationship between the unemployment rate and rate of growth of money wage. If unemployment rate increases, rate of growth of money wage, that will fall or rise?
Fall.
Fall.
That will fall. Okay, that will fall. Now, under perfect competition, what is the relationship between marginal cost and price of the commodity?
P equal to MC.
P is equal to MC, everybody? Under perfect competition, P is equal to MC? Yes. Okay. This principle is called the markup pricing principle. Markup pricing principle. Price is based on incremental cost of production. This system is called markup pricing. Markup pricing. Are you familiar with the term markup pricing?
No, ma'am.
Okay, so please Google this. So this,
ma'am, it is a pricing when the good is basically marked up because it is maybe new or it is like not like old stock. So when we go to a shopping mall, some are in discount, which is the old stock, but then some are marked up, which are the newest collections. And after a few maybe days or weeks, the price then returns to normal again.
Udita, this is not the concept which we use in context of economics when we call it a markup pricing, okay?
Ma'am, is it like the selling price is more than the cost price?
Yeah, so first Google this thing, you know, so check everything, why we call it a markup pricing principle, okay? So I'll be not able to tell you, check Baumol's book, So Baumol's book is the best reference to understand why this competitive price is called the markup price, So better you Google this thing, and next day, again, we will consider the idea of markup pricing principle. Okay, why we call it the markup pricing principle. Okay, so Udita, this is not the right concept which economists consider while they consider it to be a markup pricing. Okay, so please look at this thing. Why marginal cost pricing principle is called the markup pricing principle. Okay, so P is equal to MC, that everybody has knowledge that under perfect competition, price will be determined by marginal cost, incremental cost. So this is the second point. First point is unemployment. As unemployment rate increases, rate of growth of money wage will fall. So there is an inverse relationship between unemployment rate and wage rate. This is first point. Second point is, under a perfectly competitive situation, we go for markup pricing principle, where price is exactly equal to incremental cost of production, marginal cost of production. Third point, therefore, we can relate the change in wage rate with the change in price. If we follow the principle, price is equal to marginal cost, in that case, if we consider a change in wage rate, that will be related to the notion of change in price. Is it acceptable, the third point?
Yes, ma'am.
Because if we consider the change in wage rate, we are talking about change in MC. So if P is equal to MC, naturally change in MC will be related to change in P. So if in an economy, there is continuous increase in money wage rate, that will result in continuous increase in price. So in an economy, if money wage increases, if the rate of growth of wage is positive, in that case, rate of growth of price is also positive. Rate of growth of price is also positive. That is, price of the commodity will continuously increase. Fourth point, if the price of the commodity continuously increases, that is called inflation. That is called inflation. If price of the commodity is continuously increases, that is called inflation. Okay. So first we started with an inverse relation between rate of growth of wage and rate of growth of unemployment. Then we are relating the rate of growth of wage with the rate of growth of price. There is a positive relationship between rate of growth of wage and rate of growth of price. Okay, so we can present a relationship which will present interrelation between rate of growth in price and rate of growth in unemployment. Okay, so finally we will relate rate of growth of price with rate of growth of unemployment. I'm repeating, first point, rate of growth of wage is related to rate of growth of unemployment in an inverse way. First point. Second point, we are considering markup pricing principle. That is, price is equal to MC in our system. So in that sense, if there is a continuous increase in MC, there will be a continuous increase in price. In other words, if there is continuous increase in money wage rate, there will be a continuous increase in inflation of the economy. So third point, therefore, we can interrelate the inflation rate with the unemployment rate. Instead of relating money wage rate we can relate inflation rate with the unemployment rate. Since there is a positive relationship between money wage rate and inflation rate, naturally, the same relation between money wage rate and unemployment rate will be continued if I replace the money wage rate with the inflation rate. That is, there will be an inverse relationship between inflation and unemployment rate. In an economy, if there is continuous increase in unemployment, in that case, price of the commodity will fall continuously. That is, that there will be deflation. If there is continuous increase in unemployment, there will be a reduction in price. The relation Kritika told us, the interrelation between inflation rate and unemployment rate, inverse relation between inflation rate and unemployment rate. And therefore, many a times you will find that policymakers are telling that generation of employment is a costly matter, because if we generate employment too much, in that case, there will be an inflation in the economy. Okay, so this kind of policy decision you will find, so we are not generating employment because of the fact that it will result in inflation, okay, in continuous increase in price. So in brief, if we look at the point again, rate of growth of money wage is a function of rate of unemployment. In an economy, as unemployment grows, that indicates surplus labor. This in turn indicates decline in money wage rate. This was the first analysis given by Phillips relation. Later, following the markup pricing principle, P is equal to MC, Phillips curve tried to relate the rate of growth of inflation to rate of growth of the unemployment. Okay, so continuous increase in wage rate increases additional cost of production. This in turn increases price of the commodity. Okay, and therefore, as there is a positive relationship between inflation rate and money wage rate, so if instead of money wage rate in the first equation we bring inflation rate, this will give the same inverse relation between inflation and unemployment. So this is our starting point. This is our starting point. Okay. Okay, so please go through these points. One of the most widely used concepts in the analysis of inflation and unemployment is the Phillips relation. In original formulation, it depicts a negative relation between rate of growth of money wage and rate of unemployment. W is equal to F of U, where F prime U is negative. W indicates the rate of growth in money wage. U indicates rate of growth in unemployment. Later usage, however, has adapted in the Phillips relation into a function that links the rate of inflation to the rate of unemployment. This adaptation may be justified arguing that markup pricing P is equal to MC principle is in wide use, so that a positive W means positive growth of wage rate, reflecting growing money wage cost, would necessarily carry inflationary implications. And this makes the rate of inflation, like W, a function of unemployment. Okay, so up to this, I hope you understood the point. Next, we will modify the relation. We will not say that rate of growth of price, small p is the rate of growth of price. It is indicating the inflation rate. We are not telling that, just a minute, we are not telling that inflation rate is exactly equal to rate of growth of money wage. Okay, so the paragraph which I have given just above, looking at this, you may consider rate of growth of price is exactly equal to rate of growth of money wage. Okay. However, if we look at the functions of an economy, we will find that inflation rate is not exactly equal to rate of growth of money wage. Why? Because over time, in an economy, as the wage rate is increasing, productive capacity of the labor force may increase. How? As the wage rate increases, we will go for better food, better education, better living condition. So in an economy, if wage rate increases, that will result in better living condition, betterment in food, betterment in education, everything. So quality of the labor will increase. So as quality of the labor improves, that brings additional productivity in the system. So capability of existing labor force in the economy, that increases. So inflation rate will be equal to rate of growth of money wage minus that productive capacity, change in productive capacity, increase in productive capacity. Okay. So if you look at the sentences, the inflationary pressure of a positive W, however, be offset by an increase in labor productivity. This is assumed to be exogenous and is denoted by T. Why in this model we are considering this to be exogenous? Because here our focus is on money wage. However, from the other source of knowledge, we know that if we improve the wage rate, if we improve the income in the hand of the people, existing labor force, their ability, capability, productivity will increase. Okay, so in this model, we are considering this to be exogenous. Okay, this interaction between income and productive capacity, that is exogenous. However, we are understanding that there will be this issue too. So this is assumed to be exogenous. However, we are understanding this improvement in labor productivity will occur. So inflationary effect can materialize only to the extent that money wage grows faster than productivity. Okay, so it's not that as wage rate increases, always you will have inflationary pressure. As wage rate increases, if there is sufficient increase in labor productivity, in that case, price of the commodity may fall even. If T is greater than W, in that case, there may be reduction in price too. Policymakers never tell about this scenario. Okay, so they always, show that, if we increase wage rate, in that case, there will be a continuous increase in price. Okay. However, as students of economics, you have to understand all underlying issues. As W increases, that in turn increases productivity. So in an economy, it is not necessary that an increase in wage rate will always create inflationary pressure. Okay? If and only if rate of growth of money wage is greater than that of labor productivity, in that case, there will be inflationary pressure. However, never it is equivalent to that of increase in wage rate, because there will be at least some increase in productivity. Okay, so denoting the rate of inflation, that is the rate of growth of price, as P, we may therefore write this equation as P is equal to inflation rate is equal to rate of growth of money wage minus the productivity, minus the increase in productive capacity, which we are considering to be exogenous. Now, if I consider the relation between W and U, a linear one, I can present it as W is equal to alpha minus beta U. W is equal to alpha minus beta U, where alpha beta positive. That indicates there is an inverse relationship between W and U. So in the inflation equation, I can substitute W by alpha minus beta U and can present the equation as P is equal to alpha minus T minus beta U. This is adapted version considering a linear FU. Why this is adapted version? Because as I mentioned, Phillips actually started with the relationship between W and U, not between P and U. Later, Phillips adopted this version. Okay, therefore, this is the adopted version which consider the relationship between inflation and unemployment. Since we are considering a linear relationship between W and U, the similar type of linear relationship will be considered in context of inflation equation. Now, somebody had some question. Yes. The earlier part or this part? Any question? Any clarification?
Could you show the paint once more? The paint slide.
This part.
Ma'am, that was whatever was written in the paint. I could not copy all of it.
Okay, so this will be there in the recording. Then you will look at the recording and copy these things. Okay.
Ma'am, I have a question from here.
Yeah.
Ma'am, here you are saying that T is exogenous, means this is the technological change which is occurring over a time, means which improves labor productivity. Ma'am, but the explanation you gave was that T is a function of W itself, means as W rises, then the productivity will rise. So it is then not exogenous, it should be included in the model.
Here in the, the change in productivity, because directly W is not changing T. Okay. Directly W may result in, okay, there is some may result in better education, may result in better food practices, may result in better living condition. If all these things or some of these things occur, in that case only there will be an increase in productivity of the labor force. Okay, so if I make this T endogenous, in that case we have to go for a number of assumptions. It may happen that increase in wage rate, there is some increase in wage rate, however that cannot give that big push so that the education level is increasing, at least to some extent, so that you can move from one kind of job to another kind of job. Okay, so there are many things. So if I make T endogenous here, so in that case I have to make further assumptions. This proportion of increase in wage rate will be necessarily spent on education. This proportion spent on improvement in living condition. This proportion spent on improvement in other thing. Okay, so improvement, we have to make a lot of assumptions, that is this proportion of increase will go for these, this proportion of increase will go for these. So we are not going for this kind of things. As we will move, you will find that itself, it is a very complicated model. Okay, so we do not want to increase the notational complications in terms of T again. Okay, therefore we are telling that the improvement in wage rate in general increases the productivity at least to some extent. However, this increase in productivity we are considering to be a constant. So when you will go for further higher education, you will go for research, actually in case of research we do that. We twist the models little bit. We collect the empirical observation on some variables which will help us to twist the model a bit. And then again we measure what is happening. Okay, so here as the beginner, we are trying to understand the basic nitty-gritties of micro as well as several macro frameworks. So we are not complicating the model with the variables or the parameters which are not that necessary. Okay.
Yes, ma'am. Thank you, ma'am.
Any other question for the modeling part? Okay, so everybody got this equation. This is basically our starting equation. This is basically our starting equation to frame the second order. Here we will have second order difference equation framework, So this is our starting model. Inflation rate is equal to alpha minus capital T minus beta U. Okay, everybody, the starting equation is fine to all of you?
Yes, ma'am.
One more factor actually we will consider when we will bring the time element in this version, adapted version of inflation equation. Okay, we will consider the expected rate of inflation too. In this framework, we will incorporate expected rate of inflation too. Okay, so let me proceed and check how we will further edit this equation a bit. Again, the expectation augmented version, this is the adapted version of the Phillips relation. P is equal to alpha minus T minus beta U, that is the adapted version, okay? Now, we are going for expectation augmented version of Phillips relation, this relation. Okay, so the expectation augmented version of Phillips relation between inflation and unemployment can be presented as, now I am bringing the time element in our discussion, PT, price or inflation rate of the tth period. Inflation rate of the tth period is a function of unemployment rate of tth period, and pi t, where pi t is the expected inflation rate, expected inflation rate. In context of macro, lots of prediction and forecasting takes place. Lots of prediction and forecasting. What will be the expected rate of interest? What will be the expected inflation rate? Okay, expected rate. So lots and lots of forecasting. Now, in our state, the election is going on. You are finding that lots and lots of forecasting. Expected result. Okay, so expectation. So expectation plays a huge role when you consider the dynamics of economics. Okay, in context of any social sciences, expectations has a very, very important role. Therefore you will find that in your syllabus there are lots of probability, set theory, expectation, all these things are going on parallelly, all the tools you are learning, because we economists, try to assess or judge a variable or try to find out the value of the variable many a times, incorporating the expectations, uncertainties in our model. So Philip's augmented version of inflation is like this. Inflation rate of this period is not only function of unemployment rate, but also function of what is the expected inflation rate. This has been calculated on the basis of the past inflation rate. I'll go for an equation for pi t. Okay, so how we actually derive or get some idea about pi t. Okay, so this is the version which we are calling equation number 1. This is the complete version where pt is a function of ut and pi t. Okay, look at the right hand side, alpha beta greater than 0. Earlier also I mentioned about this. Here I'm mentioning the possible range for g. G is greater than 0, strictly greater than 0. However, less than equal to 1, less than equal to 1. Okay, so this is the value of g. Positive fraction, maximum value is 1. So pi t is the expected inflation rate. So now look at this equation number 1. Here we can derive 3 types of time paths. Okay, 3 types of time path. First, the time path for inflation rate. Second, time path for unemployment rate. Third, time path for expected inflation rate. All these things, all these time paths are very, very important in macro discussion of any economy. You know, what will be the pattern of unemployment over time? What will be the pattern of expected inflation rate over time? What will be the pattern of actual inflation rate in an economy? Okay, so 3 models are equally important. So I hope you are understanding. It's a large thing. So from equation 1, we will proceed in such a way so that we can derive 3 types of time path using the second order difference equation. Okay. As I mentioned, I'll tell you something about pi, something about pi. Now, regarding pi, or while we are framing the notion of pi, the expected inflation, these can be modeled in different ways. Okay. Among these different ways, the 2 ways are very popular. One is adaptive pattern, okay, and adaptive expectation model. This we will use in our framework. And there is rational expectation model too. Okay, so that we will not use at this stage. At the undergraduate level, we will not use that. However, that is also very popular, rational expectation model. So for the time being, we will consider for pi t, framing some idea about pi t, we will use the adaptive expectation model. This is presented by pi t plus 1 minus pi t. So what will be the expectation of the inflation in the next period? That is pi t plus 1 minus pi t. That is the difference between the expectation of t plus 1th period and tth period is a function of, positive function of actual inflation rate minus expected inflation rate in the present period. So additional change we will expect in t plus 1th period, additional change which will be given by pi t plus 1 minus pi t. Additional expectation or addition to my expectation is a function of actual inflation rate and expected inflation rate in tth period. where j is again lie between 0 and 1. The maximum value is 1. Okay. That is, pi t plus 1 minus pi t is exactly pt minus pi t. However, it may be smaller than that. However, it is positive. Okay, it is positive. So this is the adaptive expectation model. Any question? If pt is greater than pi t, then pi is revised to the upward direction and vice versa. However, if pt is less than that of pi t, what the economy predicted, or statisticians or econometricians predicted, from that, if the inflation rate is lower, in that case, your expectation for the next period will fall. So, if pt greater than pi t, that is, this difference is positive, then pi expectation will be revised to upward direction. I'll expect that next year inflation rate will be higher, and vice versa. Vice versa means if pi t is greater than pt, present period expected inflation is greater than actual inflation, in that case we will revise it to the downward direction. My expectation of increase in price or inflation rate will be reduced. Okay, next. The monetary policy equation is stated as, in this framework, the monetary policy equation is stated as ut plus 1 minus ut. That is, unemployment in t plus 1th period minus unemployment in tth period. These are all growth rate of unemployment of t plus 1th period minus growth rate of unemployment in tth period is a negative function of money supply minus inflation in the next period. Okay.
Ma'am, can you repeat?
Yeah. Unemployment growth in t plus 1th period, that is 2021, minus unemployment, growth of unemployment in 2022 minus growth of unemployment in 2020. Okay. Growth of unemployment in the next period minus growth of unemployment in this period is a function of, first we understand the functional form, is the function of the money supply which the economy will have in its hand minus the inflation rate which the economy will face in the next period. So money supply, that is exogenously given. We will consider this is a policy matter. So this is a parameter. This is exogenously given. It is based on monetary policy. So in our framework, this is exogenously given. What will be the volume of money supply? So volume of money supply less inflation in the next period, that we are considering in the right hand side. Rate of growth of unemployment minus rate of growth of unemployment of next period minus rate of growth of unemployment of present period, that depends on this expression. Now this is a negative function of m minus pt plus 1. Okay. Now m minus pt plus 1, that indicates surplus money in an economy. This is the money supply part and this is the increase in price part. This is the increase in price part. Okay. So money supply part less the inflation we are considering. Money supply less the inflation we are considering. Okay. So in some sense, it is the real income. It is the real income because it is the money supply less the inflation in the next period. So it is the real income, okay? So change in unemployment rate is a negative function of real income. If real income increases in an economy, then unemployment rate will decrease. If real income in an economy increases, then unemployment rate in the future that will decrease because there is a negative sign and K is positive. Okay, so would you please note down, if real income in an economy increases, that indicates better purchasing power. Real income of an economy increases. That indicates better purchasing power. This in turn increases an improvement in employment situation. An improvement in employment situation. More people are in good shape. That means, economy, with respect to employment, is also in a better shape. Okay, so if real income of an economy increases, that in turn indicates in future unemployment rate will fall. Okay, is it understandable? Here we are bringing aim. So this is the monetary policy equation. So for equation 3, we are stating that 3 endogenous variables in equation 3 are inflation, actual rate of inflation, pi, expected rate of inflation. Actually, I can bring pi here, so there are interrelationship between P and pi, so I can bring pi here. So 3 endogenous variables in equation 3 are P, pi, and U. Several parameters appear in this model. The parameter M, several parameters means there is K2, the parameter M, and if you in fact replace P in terms of alpha, beta, U, etc., in that case you will have a number of parameters. The parameter M, the rate of growth of nominal money or the rate of monetary expansion, differs from other parameters in that its magnitude is set as a policy decision. What will be the volume of currency that will be circulated in an economy? That is a policy matter. Okay, so in an economy, suppliers or demanders, they will be not able to determine this thing. Only this is a policy decision. Those who will be in the Ministry of Finance, they will decide on this matter. What will be the money that will be circulated in an economy? So aim, what will be the magnitude of aim? That is not in hand of any other agent in an economy. That is totally in hand of policy makers. Okay, so m in that sense is different from other parameters which we will have in this model as this is a policy decision. Any question regarding equation number 3?
Ma'am, here M is the like, is it a stock variable or a flow variable? Like, is it the current money supply in the economy, or is it the rate of growth of this expand, like the monetary expansion, like it's mentioned here?
Nominal money. Look at this. You know, this is the rate of growth of nominal money or the rate of monetary expansion. Okay.
Okay, so in this model, each variable is representing the rate of growth of that concerned variable.
Yeah, rate of
Okay,
growth.
okay,
Everything
okay,
is
ma'am.
in terms of rate of growth.
Thank you, ma'am.
Now, I'll substitute, you know, the equation 2, equation 3 in equation 1. Okay. So I'll write a big equation for equation number 1. So following equation number 1, slowly actually we will do that. First, following equation number 1, it is in terms of PT. I'll write it in terms of PT plus 1, UT plus 1, pi t plus 1. Why I'll do so? Because if I do this thing, I'll get a new equation. After that, I'll subtract this equation from the new equation so that I can use pi t plus 1 minus pi t, ut plus 1 minus ut. These things I can put in the master equation. So first, I'll consider the equation number 1 and write the version with t plus 1. Then I'll subtract equation number 1 from the new version. So I'll get pt plus 1 minus pt. I'll get ut plus 1 minus ut. I'll get pi t plus 1 minus pi t. Once I get this, I'll substitute equation number 2 and equation number 3 there. Are you understanding my objective?
Yes, ma'am.
Ma'am, can you do this?
Yeah, I'll do that. I'll definitely do that. And with me, you will also do this thing. Or you are asking whether we can do this thing.
No, ma'am. I'm asking if you will show the procedure.
Yeah, I'm showing. I'll just do these steps now. So pt plus 1, please write down this is alpha minus t minus beta ut plus 1 plus g pi t plus 1. Okay. Just I am advancing equation number 1 by 1 period. Then I'll consider delta pt, which is pt plus 1 minus pt. That is, I'll, take the difference of equation number 1 from this equation. Okay. So pt plus 1 minus pt. Please look whether you are getting this. Alpha, alpha, tt will be cancelled. So please check whether you are getting this or not. Minus beta ut plus 1 minus ut plus g pi t plus 1 minus pi t. Once we get this thing, I'm substituting equation 2 and 3 in equation 4. ut plus 1 minus ut, I'm replacing by minus m minus pt plus 1, and pi t plus 1 minus pi t, that I'm replacing by j into pt minus pi t. So please do this thing and tell me whether you are getting the same or not. There are lots of notations and signs and the big equations, therefore I'm using the word version. If there is any difference between your calculation and mine, I'll change the sign, etc. if there is any mistake in my calculation. Once you do this, please let me know whether you are getting this or not. Raunak, is it okay?
Yes, ma'am.
So everybody could complete up to this?
Yes, ma'am.
Okay. And all the signs, everything all right here? Those who derived, you are getting the same result or difference is there?
Ma'am, I'm getting same.
Ma'am, I got the same.
Okay.
Same, ma'am.
Okay. So, first, I told you from the Phillips relation, actually, I'll try to find out the time path of inflation rate, time path of unemployment rate, the time path of pi t, the expected inflation rate. First, I'll try to derive the time path of actual inflation rate, that is PT. So if we look at equation number 4, most of the terms are, PT plus 1, etc. So in terms of P, however, there is one pi. There is one pi that I have to present in terms of P. Okay, so first, my objective is to find out the time path of inflation rate. Time path of inflation rate. So if we look at the equation 4, in the left-hand side, everything in terms of PT, right-hand side, PT plus 1, PT is here. However, there is 1 pi t. So I have to make everything in terms of P. Are you agreeing? If you want to find out the time path of inflation, everything you have to present in terms of P or not?
Yes, ma'am.
Yes, ma'am.
Okay. So to eliminate pi t from the above equation, we consider equation 1 where g pi t is equal to pt minus alpha minus t plus beta ut. So what I'm doing, I am using equation number 1, g pi t I'm keeping here and rest of the things in the right hand side. The problem will be ut will appear and I have to handle that issue too. So first, I am considering g pi t equal to rest. G pi t in the left and rest in the right. Okay. So g pi t is equal to pt minus alpha minus t plus beta ut. Okay. Substituting this in equation 4. In equation 4, I have pt plus 1 minus pt is equal to beta k m minus pt plus 1 plus jgpt separate minus jg pi t. jg pi t. So in place of g pi t, I'll put all these letters. So please do and check whether you are getting this or not. Please do it on your own. If there is any mistake, please let me know. Please don't copy, do the things on your own. Otherwise, you will not understand the nitty-gritties. These are big equations. So please do the things simultaneously. In equation number 4, we are putting g pi t. Could you complete?
Doing, ma'am.
Shomosri, Ovipsha, Shomadrita, are you getting these results?
Yes, ma'am.
Rest of the students, everything is fine or there is some difference? Is it okay to everyone? Everybody got equation number 5?
Ma'am, I got it.
Yes, ma'am.
Yes, ma'am.
Okay. So, in equation number 5, is there any extra element which we need to change? To get
UT.
the PT? Yes.
UT.
UT is the extra element. Okay. Now look at the UT equation. That is, in terms of PT, if I can have UT plus 1 minus UT. UT equation can be presented in terms of PT only. However, I need UT plus 1 minus UT. So what I have to do? What I have to do? Once I get equation number 5, what I'll do? Anyone? Prithviraj? How we will proceed?
Ma'am,
Ma'am,
can I?
there is an extra element UT plus 1. What will
Yeah,
do with this?
UT.
Ma'am, can we calculate the time path of UT?
Later we will do that. Now we are trying to find out the time path of PT only. I told you we have to derive the time path of UT. I have to derive the time path of pi t. Now we are proceeding to derive the time path of PT only. So why we will, are these coming up to this? Why we will go for calculating the time path of UT?
Ma'am, can I try?
Will we consider the, like, just how we advance the time period? Can we go
And
back?
we'll
Like,
advance the time period and we'll subtract.
yeah,
Yeah,
like that's what I meant. Like t
that's
minus
how we
1.
will do. Very good. We have to advance equation number 5 by 1 period first. That is 1 plus beta k pt plus 2 minus 1 minus j into 1 minus g pt plus 1 j beta ut plus 1 is equal to beta k m plus j into alpha minus t. That will be equation number 6. Subtract equation number 5 from equation number 6. So you will get ut plus 1 minus ut term there. And in ut plus 1 minus ut term, you plug equation number 2. So please proceed in that way. Advance equation number 5 by 1 period. So to eliminate ut from equation 5, we consider the equation for ut plus 1. Everybody, please write down the equation first. You have to do nothing. You have to advance the time by 1 period. That's all. Right hand side will be similar. Only in the left hand side, you are having pt plus 2, pt plus 1, ut plus ut plus 1. Okay, so I hope everybody got this equation. Equation number 6.
Yes, ma'am.
So now you have to subtract 5 from 6. So subtracting 5 from 6, we get.
Ma'am, I've subtracted.
Yeah. Please subtract, and then in place of ut plus 1 minus ut, plug equation number 2. First subtract 5 from 6. Could do it?
Yes, ma'am.
Yes, ma'am.
So check whether equation number 7 looks like this.
Yes,
Yes,
ma'am.
ma'am.
Okay. So you are getting homogeneous kind of thing, you know. Right hand side is equal to 0 because the constant terms remain same across the two equations. So plugging that ut plus 1 minus ut equation here, plugging equation number 3. Okay, so that was equation number 3. In equation number 7, we get this one. Just rest of the things are similar. In place of ut plus 1 minus ut, I'm putting minus k into m minus pt plus 1.
Ma'am, could you please show equation 6 once?
Mm-hmm.
Ma'am, equation 6.
Equation 6.
Yes, ma'am, I couldn't copy it. So,
Okay. This one.
thank you, ma'am.
Okay. So everybody is at equation number 8.
Yes, ma'am.
So for rest of the students, what is happening? I'm not understanding.
Yes, ma'am.
Okay. So this is equation number 8. After that, please stop writing and look at the thing. Once you get equation number 8, please stop writing and look at the things. So what I'm doing, I am bringing the coefficient of pt plus 2 with pt plus 2. Now pt plus 1 is coming 3 times. Here there is a pt plus 1, that is minus of 1 plus beta k pt plus 1. Here I have pt plus 1, that is minus 1 minus j into 1 minus g pt plus 1. And here also I have pt plus 1. Okay, minus kj beta pt plus 1. So we are getting pt plus 1 3 times here. So I'm keeping all the coefficients of pt plus 1 together, taking pt plus 1 common. Then pt is here. With pt, the coefficient will be plus, minus and minus plus, 1 minus j into 1 minus g. So this. And if there is any constant term, I'm keeping it to the right hand side. So I'm taking pt plus 2, pt plus 1 and pt common. And if there is any constant term in the entire process, actually this is the constant term, minus j beta km. This is a constant term. That I'm keeping in the right hand side. Okay? Since there is a big thing with pt plus 1, in the next step, I just adjusted the thing, just rewritten the thing to check whether I can cancel several elements from here and there, etc. Okay. So between this line and the next line, there is no difference at all. Just I tried to simplify the coefficient of pt plus 1. That's all. So please do it on your own. Take common pt plus 2, pt plus 1 and pt. Do it on your own because these are very notational matters. If you try to copy, there will be some mistake. There may be some students who may feel that later I'll do this thing because I'm getting the recording and I'm getting everything there. However, it will be difficult to understand the things later if you don't do these things simultaneously. Please let me know once you take common, you can complete that step. If there is any after that, please compare it with the results in the screen. If there is any difference in coefficient in terms of sign, please let me know.
Yes, ma'am. Got it.
Same thing, got it?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Rest of the students?
Yes, ma'am.
Okay. So I have to reach at equation number 9, which is a second order difference equation in PT. So you did up to this. I'm trying to, if you look at this line, 1 plus beta k pt plus 2 as it is minus 1 plus jg, what I did, I have taken 1 plus beta k common. So 1 minus j into 1 plus beta k. It is 1 minus j into 1 plus beta k. So if you take actually j common, you will have another 1 plus beta k. So it is 1 minus j into 1 plus beta k. The next term is same. Once I get this thing, I will keep pt plus 2 with the coefficient 1 and divide the rest by 1 plus beta k. And we'll have equation number 9. Equation number 9 is a second order difference equation in PT. In P, you can say. Please check whether you are getting this or not. So only the first step will be completed once you write equation number 9, that is getting the second order difference equation.
Yes, ma'am, got it.
None got it. Very good. Coming to this step, what you can do, you can consider Pt is equal to b to the power t. So you will get b to the power t plus 2, b to the power t plus 1, b to the power t, etc. Okay. Since already we have knowledge about how to proceed, how to derive the time path using a second order difference equation, directly I'll consider this as the quadratic version and we'll talk about 2 roots of the model. Okay. However, if you like, you can proceed in that way. Pt is equal to b to the power t, and then from there b square, the equation with b square, etc. that also you can generate, and you can write the 2 values of the roots from that quadratic. However, as we have knowledge about this thing, that is, this is equivalent to the quadratic in B if I consider Pt is equal to b to the power t. Therefore, directly from this equation, I can talk about 2 roots of the model. Okay. So next, the relevant or the 2 roots of the quadratic, 2 roots of the quadratic characteristic equation, the 2 roots of the quadratic characteristic equation of equation number 9, the 2 roots of the quadratic characteristic equation of equation 9 are given by please write down the root values, are given by b1 comma b2 is equal to, or you can write r1 comma r2. Since you have no quadratic in terms of b, you can call the roots using any name. You can call the roots b1, b2, r1, r2, no problem. That will be equal to minus b plus minus root over b square minus 4ac by 2a. So once you are at equation number 9, please write down the values of the two roots for the underlying quadratic characteristic equation of equation number 9. Once you get the root value, please let me know what is the value. Oyon, would you tell me what are the values of the roots?
I'm calculating.
Okay, yeah. Do it and then tell me. Use the formula minus b plus minus root over b square minus 4ac by 2a. So first you have to write this big thing. Minus b means this big thing. So this thing will be there without the minus sign because it is with the minus sign. So when you are writing minus b, we will have 1 plus jg plus 1 minus j into 1 plus beta k divided by 1 plus beta k. Then plus minus root over of this thing square of this minus 4, a is 1, c is this element, divided by 2 only because a is 1. So Ayun, could you complete? Or anyone could complete?
Yes, ma'am.
Please tell me the value.
Ma'am, it will be 1 plus jg minus 1 minus j into 1 plus beta k whole divided by 2 into 1 plus beta k plus minus root under bracket a 1 plus jg plus 1 minus j into 1 plus beta whole square by 1 plus beta k whole square minus 4 into 1 minus j into 1 minus g by 1 plus bk whole divided by 2.
By 1 plus beta k. Yeah, there is a mistake. There will be a by. And I think, who are you?
Ma'am, my name is Shampriti.
Shampriti, I think there is a mistake in the sign of this part, you know. You please repeat the sign once again.
Ma'am, the sign is correct only. It will be just in the denominator 1 plus beta k into 2. There will be into 2.
Yeah. And here b square minus 4ac, there is divide.
1 by 1
Ma'am,
plus
1
beta
plus beta
k
k
will
is
be divided. Will be.
Is this all right?
Ma'am, also in that first part, like after that whole divided square, it will also be divided by 1 plus beta k whole square.
I think now it is all right. Everybody got this value?
Yes, ma'am.
Okay, so keep the roots like this. Okay, while we will talk about the stability, we will talk about whether the time path is monotonic and divergent. Our focus will be on these two root values. Okay, so next, once we get equation number 9, I'll be able to find out PE. Okay, it is easy to find out PE. So please derive PE. For intertemporal equilibrium, we set PT plus 2 is equal to PT plus 1 is equal to PT is equal to PE in equation number 9. For intertemporal equilibrium, we set all the time value is equal to PE. So, using equation number 9, then, please derive the equilibrium price. Equilibrium inflation rate, equilibrium inflation rate. Using equation number 9, tell me what will be PE. Equilibrium rate of inflation. And that will be equivalent to PI, particular integral.
Ma'am, is it M?
Yes.
After all striking, after all calculations.
M, very good. This will be M. It will be equal to money supply. Equilibrium inflation rate will be equal to the money supply in the economy. So everybody is doing that and trying to find out PE.
Yes, ma'am.
You are getting this to be equal to M.
Yes, ma'am. Got it. M.
Call it equation number 10. So equilibrium inflation rate is equal to rate of money expansion. Okay. So some people had economics at +2 level, and I think you found that you will many a times in the textbook of +2 it is written that if we go for currency printing etc., that will be inflationary in nature. Currency printing may bring inflation. Have you got this kind of statement?
Yes, ma'am. Many times.
Many times, yeah. Okay. And those who didn't have economics, no problem. Later you will get this statement, especially when you go through the news or media, you get the news for the entire economy. So you will get this kind of statement. We will not go for printing the currency or directly using the money supply in an economy because that will be inflationary in nature. This is the basis of giving that kind of statement. However, if you increase the money supply, there may be other channels too, which may help the economy to boost up. That may increase effective demand. and that may result in, better employment, better many things, However, in general, policymakers make this kind of statement: if you have more supply of money in an economy, that will be inflationary in nature. Okay, so I think by this time everybody got the equilibrium inflation rate, which is equivalent to rate of money expansion. Okay, and equation 10 is also giving us the PI, the particular integral for the second order difference equation. Okay, I have added a note to derive the complementary function. We consider the deviations between each P and PE, as we did in case of Samuelson or Hicks-Samuelson model. We will consider PT plus 2 minus PE. We will consider PT plus 1 minus PE. We will consider PT minus PE. So we will consider the differences. Okay. So this thing will be there. Okay. Now for the complementary function, there are three possibilities: distinct real roots, repeated real roots, complex roots. Depending on the discriminant of the quadratic. Okay.
मैम आगे स्लाइड टेक में देखो ठीक है सर
So at this moment you can write that equation, the difference of the entire thing from P, that is, you can consider equation number 9 and you can generate PT plus 2 minus PE, PT plus 1 minus PE, PT minus PE. So you can generate that term, So once we learn these things, we generally do not repeat the things, So keep this thing in the note, or if you like, you can write all these steps. So for the complementary function, as you know, we will consider these possibilities: distinct real roots, repeated real roots, and complex roots. Okay. And you will get distinct real roots, repeated roots, real roots, and complex roots depending on the fact that whether this whole square is greater than, equal to, less than these 4 into this part. Okay, so look at the root values. Okay, so root values are there. So everything will depend on this part. Everything will depend on this part. Okay, and while you are keeping this part, the first part in the left hand side, second part in the right hand side, you can adjust these 1 plus, this divided by 1 plus beta k whole square component. So please check whether you are getting this.
Yes, ma'am.
Yes, ma'am.
Okay, so equation 11 is fine.
Yes, ma'am.
Okay, so once we get equation 11, I'll go for B1 plus B2, B1 into B2, 1 minus B1 into 1 minus B2. And after that, if roots are real, what will happen? If complex, real, distinct, what will happen? If the roots are repeated, real, what will happen? Complex conjugates, what will happen? So all these things I have to do. So that we will do in the next class. So first you check up to equation number 11 and the nature of the time path I'll discuss in the next class. Nature of the time path, I'll discuss in the next class. Wednesday, I'll discuss about all these things. Okay, and also calculate or also try to derive the time path of unemployment rate, the time path of pi t. So that will complete the entire discussion based on Phillips curve. So actually we will need two more classes to complete this thing. Okay then. Do anyone have any question up to 11? Some people told me, you didn't get time to complete this thing. If you like, please complete this thing. Attendance, I think I completed.
Ma'am, was I not present?
Who are you?
Ma'am, Udita.
What's your roll number? Udita, I think you didn't join when I called the roll numbers.
Yes, ma'am, I joined a bit late today.
What's your roll number? Yeah.
78.
Anyone else?
Ma'am, I am Priyasha. Even I haven't been marked yet. Ma'am, Komal is saying that she's present.
Yeah. Arman is there? Raju,
Yes, ma'am. Ma'am, he wrote in the chat box.
he's there.
Yes, ma'am. He had messaged around 11:20.
Yeah. Okay. Rajoshi? Rajoshi is absent today. Anandarupa is absent.
Ma'am, Anandarupa's brother had to be hospitalized. She gave it in the group. So she had to leave halfway through.
Okay. For the COVID.
Yes, ma'am.
Okay.